Hello and welcome to the Data Engineering Podcast, the show about modern data management. When you're ready to build your next pipeline and want to test out the projects you hear about on the show, you'll need somewhere to deploy it, so check out our friends over at Linode. With their managed Kubernetes platform, it's now even easier to deploy and scale your workflows, or try out the latest Helm charts from tools like Pulsar, Pachyderm, and Dagster. With simple pricing, fast networking, object storage, and worldwide data centers, you've got everything you need to run a bulletproof data platform. Go to dataengineeringpodcast.com/Linode today, that's Linode, and get a $100 credit to try out a Kubernetes cluster of your own. And don't forget to thank them for their continued support of this show. We've all been asked to help with an ad hoc request for data by the sales and marketing team. Then it becomes a critical report that they need updated every week or every day. Then what do? Send a CSV via email? Write some Python scripts to automate it? But what about incremental sync, API quotas, error handling, and all of the other details that eat up your time? Today, there is a better way. With Census, just write SQL or plug in your dbt models and start syncing your cloud warehouse to SaaS applications like Salesforce, Marketo, HubSpot, and many more. Go to dataengineeringpodcast.com/census today to get a free 14-day trial. Your host is Tobias Macy, and today I'm interviewing Matteo Merli about Apache BookKeeper, a scalable, fault-tolerant, and low-latency storage service optimized for real-time workloads. So, Matteo, can you start by introducing yourself?
My name is Matteo Merli. I've been involved with BookKeeper since several years now. I mostly use BookKeeper in the context of Apache Pulsar. That's what we had started to use at Yahoo back in the day, our messaging platform on top of Apache BookKeeper. So how I get into that. But yeah, I'm on the PMC of BookKeeper, and I'm on the PMC chair for Apache Pulsar too.
And you recently joined the Stream Native team as well.
Yes. Yeah. Continuing work on Pulsar and BookKeeper with the community, and also to help companies to adopt these technologies.
And also for people who have been listening to the podcast for a long time, they've heard you before when we talked about Pulsar when you were still at Streamlio. And so for people who haven't heard you on the show before, can you just share quickly how you first got involved in the area of data management?
Sure. So I started working at Yahoo like 10 years ago or so, and because everyone was interested in distributed systems, distributed databases, and that was like a very good place to be, to learn a lot. And one of the things that I started working on was that database replication in particular. And we had several different kind of technologies, like each developed in a different era with different designs and different trade-offs and so on. We saw all the problems that we had in operating this system at a large scale. So BookKeeper was a project that was out of Yahoo Lab at that point. It was more conceptual. It was not in production yet, but we thought that it was really a good foundation for what we want to get the data platforms to end and all these kind of data movement at a very large scale. So that's kind of where I came from.
And so digging a bit more into BookKeeper itself, can you describe sort of what it is and some of the capabilities that it offers and some of the story behind it? You mentioned that early on when you first started working on it, it was sort of a conceptual concept. Yeah, wondering if you can just share a bit more of the history of it and maybe how it went from the sort of proof of concept tool into something that you were actually using at production scale.
BookKeeper is very simple. What it offers, it gives you the abstraction of a replicated log. You think a log as an append-only data structure. And it's a service that basically you can create logs and append entry into these logs and then read those entries out. So it's very simple. At the same time, it's very powerful because you can have many logs, a lot of logs, and once you write into these logs, the data is safe. It is replicated, it is consistent, and if you crash and come back, the data will still be there. And lose nodes and data will get recopied over. So the concept of this immutable log is very powerful because it's very scalable as well. So you can have many logs and write a lot of data even on one log or many logs. So that's where it comes from. So the main idea, so why BookKeeper was created was that the initial use case that the creator had in mind was to have high availability for the HDFS name node. So name node, that had been a problem for many years, like in Hadoop, because it was a single point of failure for Hadoop, right? So one of the idea there was if you can basically write all the updates on the name node into something that is replicated and durable, outside the name node will not have any local state at any point. So you can reconstruct it. So you can have basically very quick failover for name nodes. Eventually, there was lot of things happening in the Hadoop community and didn't adopt BookKeeper. It was continued being developed as a sub-project of ZooKeeper. The same people that did ZooKeeper also worked on BookKeeper initially. That's when we started looking at it. And initially, we adopted it we had basically ActiveMQ clusters, and we wanted to have high availability for this ActiveMQ cluster, basically using that BookKeeper as a storage for ActiveMQ. And basically, we have implemented these within Yahoo, this ActiveMQ with BookKeeper service with geo-replication and a lot of other features. That was, I think, it's still in production in some form. It is still there. It was working very well, except that we had a lot of issues with ActiveMQ and JMS and so on. So that really was a bad fit for the developer experience with JMS and ActiveMQ. So what we realized was that BookKeeper was really good. And so we kept all this part that we had for storage, and that's where we basically restarted from scratch from the broker part, and we wrote Pulsar on top of BookKeeper.
In terms of the use cases for BookKeeper, you mentioned that it had a number of different inspirations as to what it was originally intended for, and it has kind of morphed into being used for a number of different cases. And one of the most well-known use cases is as the storage layer for Pulsar, as you mentioned. And I'm wondering if you can just talk through some of the other types of systems that have been built on top of BookKeeper, because of the fact that it is conceptually simple, but in terms of its capabilities, it's quite powerful due to the way that it's designed.
Sure. One other use case that we have in Pulsar for BookKeeper that is not just the data, we also keep the track of the cursors. The cursor will contain which position in the topic your consumer is, but also if he has consumed out of order messages. And this, we track that in a BookKeeper ledger, in a log. So we just keep updating that log with all the updates. Other use cases is a low-level storage API kind of system. So you can use BookKeeper to build your own database. And I think that several people actually did that in open and closed source in different forms and different ways. But you can use essentially this log as a transaction log for the database. So once you write into this transaction log as a write-ahead log, basically your write is safe and you can recover it. If you crash, you can always recover from the log. And actually, we do have one implementation of that in BookKeeper itself, which is called the table service. It is offer a key value store API, and it is built on top of BookKeeper ledgers. And it has the notion of a snapshot and the log, and both are ledgers. So you can use the ledger as a log, but also use the ledger as a blob in a way, right? You can write many entries and close it, and it's very flexible in that sense, kind of common, but yeah, you can also use it as a blob storage. In many cases, that is used as a blob storage. For example, for some functions, we needed a storage layer to store the jars. If you can submit functions as jars, as Uber jars, these has to be stored in the system. So we just store them in BookKeeper because it's available and very well for that as well.
Yeah, it's definitely interesting that because of the flexibility of it, that you're able to use it for all these different pieces. Whereas I know that sort of the biggest analogous system to Pulsar and BookKeeper is Kafka in terms of the data ecosystem, and Kafka for all of the different sort of surrounding capabilities has all these different additional deployable pieces, whereas because of the fact that Pulsar is architected on top of BookKeeper, it can take advantage of that file storage layer abstraction to store the functions as code and, as you mentioned, be able to keep track of the client positions within the streams that they're reading. That's interesting. And then in terms of the work that you're doing on Pulsar as one of the biggest projects that is actually using BookKeeper, I'm curious if you can share some of the ways that the requirements of Pulsar has influenced the features and the direction of BookKeeper itself.
Yes, in many ways, in the sense that, so we did a lot of performance work both on Pulsar and BookKeeper, and that work always crosses the boundary, right? It's on both sides. When you optimize data path, it has to be optimized in both Pulsar and BookKeeper. But other areas were in terms of expanding the number of logs that you can store in a single node. Within the years, we did rewrite the whole storage engine and how the indexing works of the entries to make it feasible to store millions of logs per each storage node. The architecture has not changed, but the implementation has improved a lot in the past years to increase the vertical scalability of each single node. And that was in reaction of needs that we had for Pulsar deployments.
And then in terms of the actual architecture of a BookKeeper cluster, I'm wondering if you can just talk through the different layers of the system and how it interacts with the hardware and some of the design decisions that you made given the high-level focus of BookKeeper as this simple, abstracted, append-only log structure?
BookKeeper cluster, it is composed of bookies, the storage nodes, right? And metadata is kept in ZooKeeper or a pluggable metadata store. Most of the logic of the replication, it is in the client library itself, and that is very powerful. And so for each log, you have the concept of a single writer. That is like a very good design choice that was done at the very beginning because it simplifies a lot of things in the replication. That single writer knows which hand has been pushed, which hand has been acknowledged, and so on. And basically, there is no need to talk between each storage nodes. So the replication is going to be a parallel write. So a client will issue parallel writes, and it will say, yeah, I want to write 3 copies, wait for 2 acknowledgements, and then the write is good. That is all tracked by the client. The nodes will have no interaction with that. So the implementation of a storage node is very like a dumb box. So you just have like a write entry or read entry, and that's it. There are no other operation or interaction that client with the storage nodes. The implementation on the storage node can be anything, right? Now the question is, you could use like a general like value store to write your book implementation. But if you look at things like RocksDB, they're very general purpose, and they have to basically, they cannot assume anything on the data, right? The keys can be updated in all these forms. But in this case, there are like few restrictions that are placed on the data itself. First, that the data is immutable. And second, that the data is sequential. And that means also that we expect the data to be like for a single log to be written sequentially and to be read sequentially, right? We try to optimize for these kind of use cases. Now, it may not be always true, but most cases it is. So therefore, like we can do better than the general purpose value store. And essentially, BookKeeper is kind of like a LSM kind of implementation because there is like a logs, compaction, but based on the fact that we know about these restrictions that are placed in this domain, we can avoid, for example, like a lot of the amplification that you will have in a general purpose value store, and just do that in a more efficient way.
In terms of the overall goals of BookKeeper and the design of the system, I'm wondering if you can just talk through some of the ways that it has changed or evolved over time as it went from this concept of something to replace the Hadoop name node to where it is now, where it's being used for streaming systems, and particularly given the shift in deployment topologies to being run in the cloud as opposed to commodity hardware that is likely to be, put into a physical rack somewhere where you have to deal with nodes that might come and go and dealing with the data replication across them.
Conceptually, like in the overall like design, there are not many changes. Like the abstraction is all the same: create the log, append entries, read entries, and close the log, and delete the log. But as I said, we did a lot of work in the storage layer, and also part of that work was to adapt to new environments. So when we started, like all the deployments that we had were basically on hard disks, on spindles, and like you had these nodes with like 12 hard disks with write controllers, with write cache and write controller. So we had to kind of like figure out that part on how to use the RAID controller, like put the journals into separated set of devices in the RAID, enable the write cache there, and so on. And with that kind of model, like we could basically use the spindle, but at the same time it had a low latency. So the main idea was that when a write goes to the bookie, it has to be gone on the journal, fsync on the journal, and then returned. So that we wanted to have that protection to not lose data in case of like power outage. Down the road, we had to kind of adapt to kind of different models, right? So especially like first, we had deployments with SSDs, and there were like some different tunables there, some different kind of like choices. And eventually we also had deployments on cloud. And that kind of changes the equation because like in cloud, you can expect, let's say, a RAID controller. You can do like a soft RAID of multiple devices, but there's not really a RAID controller with a battery-backed write cache. So you have different choices. You can either use like ephemeral storage, or you can use replicated storage like EBSs. There are like pros and cons on each of these, and we always have deployments in both of them. For example, like ephemeral storage, like these like locally attached SSDs in cloud, it is very similar to a bare metal deployment with like real disks, except that the life cycle of these disks now it is not as durable as when you were in a bare metal. So in bare metal, like as long as you write on the disk and you sync on the disk, you can recover the data unless the disk physically breaks down, right? So if you're on a spindle or like a SSD, you might stop writing. But when you write that on a ephemeral disk on the cloud, if your VMs is terminated, so is your disk. And that brings that, what is the value of like writing into a journal? What is the value of like syncing to that journal? Because if syncing there like prevents you from a power outage, if you have a power outage, your VM is gone, all your disk is gone. So because of that, we had also like deployments with like either not syncing on journal or like really not having journals, like skipping journal and relying just on replication. And for some of the use cases, again, this is like relaxing some of the durability guarantees. So it is not for everyone and not for every use case, but it's a good model. For example, like when you have like a really big amount of data volume and that data is either like you can re-ingest it or it's okay to lose some portion of it. Or we can deploy on this. We did that also like some kind of like a work to optimize for that and all the tunables that come with the EBSs. And there is more like falling in the same durability profile as before. Actually, now, so the EBS is replicated itself, but generally, like we write to multiple EBSs for more availability as well.
Another interesting design choice in the way that BookKeeper is structured is the fact that it's a record-oriented storage medium, whereas different other sort of distributed storage systems will rely more on replicating byte arrays and byte ranges and not necessarily have any concept of the record itself. And I'm wondering if you can just talk through some of the impact, benefits and trade-offs that record-oriented storage layer has in BookKeeper, particularly in terms of how that factors into data distribution and allocation across the cluster, given that the different records might be of varying sizes.
At the end of the day, like yes, each system will write bytes down on the disk, right? But one of the additional ideas that are there in BookKeeper is that you can also do striping of entries across multiple nodes. So for example, like there's a concept of ensemble size, which is which bookies should I use for this log, essentially. I could, for example, like choose to write, say, 3 copies of my data, so that each piece of data is replicated 3 times. But at the same time, I want to use, say, 5 bookies. At that point, we're doing like a round-robin striping across 5 bookies. So a single node will not have all the data, but client will know that for this entry, which 3 nodes is supposed to be out of the 5. One of the things that this feature achieves is that your throughput on a single log, it is not limited by a single node throughput. So you can exceed that amount very easily. So this is something that you can do if you have these kind of like logical breakdowns of stream into entries and you know where they are. The challenge within the different amount of size is that we typically don't know, like on the right side is fine. It's typically like on the read path that we don't know upfront, like how many entries you want to read. So the client wants to have, say, 500 K of buffer. I don't want to read 5 megabytes, and then I have to basically read too much. But we don't know upfront how much size these entries will be until we read them. So we can like struggle a bit with this for a while. And a while ago, we added kind of like basically like implementation just doing like estimating averages and correcting those averages over time. Essentially, we know like how many bytes per entry particular log. And we use that as a heuristic to when we want to read a batch of entries from BookKeeper. So that worked like very well. So I don't think that's a bigger issue right now at this point, but it definitely like is something that you have to think up front, like how much memory I'm going to need, especially like if you're not like reading from one single log, but if you have like in your single process, in your single broker, you're reading from many, many logs. Each of them can be like issuing like a batch reads and you have to basically cap the max memory.
RudderStack's smart customer data pipeline is warehouse first. It builds your customer data warehouse and your identity graph on your data warehouse with support for Snowflake, Google BigQuery, Amazon Redshift, and more. Their SDKs and plugins make event streaming easy, and their integrations with cloud applications like Salesforce and Zendesk help you go beyond event streaming. With RudderStack, you can use all of your customer data to answer more difficult questions and send those insights to your whole customer data stack. Sign up for free at dataengineeringpodcast.com/rudder today. Another interesting capability of BookKeeper is that it has built-in capabilities for life-cycling data into object storage and cold storage so that you can have a single interface to your entire storage capacity without having to keep everything on disk. And I'm wondering if you can just talk through some of the implications that that has on the ways that BookKeeper can be used and some of the design challenges that you've run across in terms of managing those data life cycles and being able to swap data off of disk, but still be able to read it into memory or be able to pass it through to the consumer for being able to access it after it's been life cycled off of the hot storage.
So actually, this implemented on top of BookKeeper. So it is more like a personal feature if you want. I mean, the line is blurred a bit, but let's implement it on top of BookKeeper rather than in BookKeeper itself. We thought a lot, we want to implement this like a tiering of storage, whether it should have gone into BookKeeper or on top of BookKeeper. The main reason we did it on top of BookKeeper was conceptually much more easier to implement, without revolutionizing how BookKeeper stores the data. So there are still advantages potentially if we could do that inside BookKeeper, because that kind of changes the equation of having the storage nodes to be a stateful node versus mostly stateless node. That would be a very interesting thing that we kept playing with that idea, but we haven't nailed down yet into a concrete form. So just to recap, right? So the way that we do the tiering storage right now, there's a component in Pulsar itself decides that a particular data ledger has crossed the threshold of say after 24 hours or X amount of storage. Therefore, we want to take it out of the hot storage, which is BookKeeper, and put it in the colder storage like S3 or DCS. At that point, what happens is that we basically do a scan of this ledger and dump it into S3, and then we delete the ledger from BookKeeper and we mark it in the Pulsar metadata that this ledger is in a different form now. It is in S3 at this obvious ID and so on. So from a user perspective, from a Pulsar user perspective, that is completely transparent, and that data is offloaded out of BookKeeper. So BookKeeper will have no tracking of that data, which works well. And say it is very conceptually easy because you have this concept of logs, that ledgers that are closed. So over time, a Pulsar topic is not one single BookKeeper ledger. It is each ledger is a segment, and these segments are closed and sealed, and they're not touched again. So we can just take one, dump it, and change metadata. So it is clean and easy. There will be advantages in doing so within BookKeeper itself. The main thing is that if you look at BookKeeper with using EBSs and journal, for high durability, one of the main bottleneck easily becomes what is the bandwidth that a single VM will have to EBS. So VMs typically are capped in the bandwidth that they have, depending on your VM type and so on. But typically, EC2 is around 700 megabytes per second or 800. Some of them would have some more the bigger VMs, but irrespective of how many EBS volumes you have, you're capped with that bandwidth. So if you write twice to EBSs, one for journal, one for storage, that basically we are kind of halving the max throughput that you can put on a single booking. So one idea there would be to basically swap the storage out so that we can use the bookie as a short-term journal, but instead of second EBS writing on a cloud storage like S3, for all the data. That basically changes a bit the picture of the bookie. It comes very short. The state is only very short-lived. It kind of removes this EBS bottleneck. The main problem here is that in the way that BookKeeper replication is done, is the client will write to 2 bookies or 3 bookies. At the same time, you're seeing that this data will get replicated into multiple S3 objects, which does not make any sense. So there has to be some more deeper change there to make it a better fit. So we're still kind of iterating on that idea.
Yeah, it's interesting that it's at a separate layer because I know that the Pravega tool, for instance, is built on top of BookKeeper and also has that lifecycling capability that it takes advantage of. So I had assumed that it was built into BookKeeper, but I'm wondering if they have their own implementation separate from Pulsar or if they're using a shared library between the two different projects.
No, there's no shared library. I think we implemented kind of the same thing all over again, I guess.
It's interesting how ideas get sort of built independently at about the same time, in similar ways without any sort of collaboration between the different teams.
Yeah, sometimes it's a waste of engineering resources, I guess. At the same time, you can move faster, if you don't have to, sometimes you start with something and then you converge to the same idea. in a way, but you start like from a slightly different point of view in a way.
And as far as the operational considerations, you've talked through a lot of the different aspects of things like the bandwidth to EBS volumes and the, whether to run with the journal or without the journal. But for somebody who's interested in deploying a BookKeeper cluster, either because they want to use it as the backing store for a Pulsar cluster or because they want to build their own system on top of it, what are some of the things that they should be thinking of as they're building out their deployment logic for setting up a BookKeeper cluster and maintaining it over its lifetime?
One of the most common thing is making sure that the disks have enough IO bandwidth. And typically people will create a smaller volumes because, I don't want to retain lots of data, but that in a cloud environment, that will also cap your IO bandwidth. So you will not be able to write fast enough maybe, or maybe the volumes are low and then the books will fill up. So these are things that are the most common issues that many people will have, how to evaluate, do we have enough bandwidth or not on the disk? And the other part, one of the things that I saw all over again is that I've seen in many cases that people have been scaling up a BookKeeper cluster because it's easy in the cloud. So, okay, I start with 3 bookies. Oh, now I have traffic spike. I will ramp it up to say 9 bookies now. And the traffic is gone. So I shrink it down to 3 bookies again. And in the meantime, you lost data because the data that was on these 2 bookies that were spun up and then tear down, then that is not there anymore. So there are tools to replicate that data, but it's kind of you need to be careful when ramping up and down a stateful system anyway, right? So you have to wait until that gets replicated when you scale down your cluster. And I've seen it happen many times. Okay, there's data missing. Why it is missing, and that's the reason.
Yeah, definitely a big oopsie.
Yes.
And as far as your own experience of working with BookKeeper and building systems on top of it, what are some of the most interesting or compelling features from your perspective as somebody who both builds the system and uses it?
Most compelling, I think, is really the replication model, the single writer model. I think that is very effective and very, in a way. But the other thing that I think that is very important is the fencing mechanism. That is, I think that this is typically overlooked and not understood, but that is very important. In a distributed system, typically you have the concept of leadership, right? So I can grab a lock on ZooKeeper, for example, and I can be the leader for this resource. The problem with this is that when you lose that leadership, you need something to validate your actions, right? So in BookKeeper, what you get is that if you are the leader, for example, I own this topic, so I'm the leader for this ledger, therefore I can be the single writer. If someone else tries to do something with that ledger, basically I'm automatically fenced off. So if someone else tries to read from that ledger and cause triggers a recovery, I am the writer, and I still think that I'm the leader for this. I should be writing, but someone else has a different opinion, so it will trigger a read. I'm automatically fenced off, and that basically I can realize that, oh, by the way, maybe I should double check again if I'm still the leader, because there is no hard barrier otherwise. So distributed lock mechanism, you need some kind of fencing at the storage level to validate your action, and that's what kind of BookKeeper offers. We actually think that is very compelling and can be used for many things. And we kind of recently in the new version of Pulsar, we kind of wanted to expose that to the user of Pulsar as well, so that they can take advantage of this fencing by having the concept of exclusive producer. As a Pulsar user, you can specify that I want to be the only writer for this topic, and that is kind of exposing the same fencing mechanism to the Pulsar user at that point. You can use that to validate your leader election by writing on the Pulsar topic as well.
And another interesting aspect of the BookKeeper architecture is you mentioned that right now the default coordinator for the BookKeeper cluster is ZooKeeper, but that is actually pluggable. And I'm curious if you've seen other implementations besides ZooKeeper for that coordination layer and what your thoughts are on the effects of ZooKeeper on the ways that BookKeeper is deployed as more things move into the cloud and become more dynamic, because I know that ZooKeeper generally requires you to statically define the members of the ZooKeeper cluster and how that reflects back out to BookKeeper.
So yeah, there is an implementation for each CD for BookKeeper metadata backend. We are also working on porting the rest of Pulsar as well to be independent of ZooKeeper, but that's a longer story here. All this kind of consensus system, in a way, you need to have a set of bootstrap nodes that you have to define. And host identity has to be stable. I don't think that there's an easy way around that, or rather than defining like an initial set of nodes. Like even if you implement your own consensus, like using Raft or anything else, right? You always have to define initial set of nodes, and from there you can discover the rest of the cluster. But I think there's no like a easy solution there that can do better than BookKeeper on that front. Sorry, than Zookeeper.
Yeah, it's amazing the staying power that Zookeeper has had, even as more things move into the cloud. And as long as the resources that rely on Zookeeper are able to scale up and down, then Zookeeper being more sort of statically allocated has, people have been able to work around that, and it's had some pretty remarkable staying power because it is, very well engineered and well considered building block for distributed systems.
Yeah. So I think that there's many good things in Zookeeper. At the same time, the semantics sometimes, like newer systems like etcd, have been moving much more quicker in a way. It can be tricky to operate Zookeeper when you're vertically scaling Zookeeper up for a lot of data or a lot of I/O. It can be done, but it's not very user operator friendly to understand why it is taking so much time to do something. You really have to dig down into the nitty and gritty details for how the little action works, to understand why it's taking 2 minutes to do a little action because the snapshot was too big and so on. So it does work. At the same time, it's not a trivial thing to operate it.
In terms of the BookKeeper project itself, I'm wondering what you've seen as some of the most interesting or innovative or unexpected ways that it's been used in systems that have been built on top of it.
So seen a very different use case, as I said, as a blob storage or as basic for key value store. Just don't think any more interesting. Kind of used by people who will be databases of or data systems anyway. I don't remember any usage out of that or any more interesting than what I mentioned already. So.
And in terms of your own experience of working on and building BookKeeper, as well as being a consumer of it and building other systems on top of it, I'm wondering what are some of the most interesting or unexpected or challenging lessons that you've learned in that process?
The most challenging lessons, I think, is really when you're using the BookKeeper for messaging, the most important thing, and I think that is most of the time overlooked. Most people don't do benchmark or load test for that. Is will I be able to read my data out? If my consumers are down for, say 4 hours, I store the data, but will I be able to read the data back while the new data comes in, right? Because otherwise, if I cannot read it faster than the data comes in, there's no point in continuing, right? Because you just keep falling more and more behind. The lessons there, even the times that you think that it would work, depending on the different patterns on the use cases and how the data gets written and read, we had to do a lot of testing and learning and tuning and re-architecting some of the storage components to make sure that is the case, that we can read data faster than it's written. And it's not always the case, because if you think that the writes are always sequential, but the reads can be scattered in some ways. So you have to make sure that you can channel that into a more sequential read and having this hierarchy of caches to make sure that you can read sequentially from the disk. So that's the most challenging part that we had with BookKeeper, I say that, but also with any other streaming data systems, because everything works fine until it does not anymore, right? So when everyone is up, everyone is caught up, then yes, all things coming from caches, then there's no challenge for any system. But the moment that you have to read a significant amount of data from disk, it is where everything falls apart in many systems. We learn some of these lessons in the hard way, and then we try to make sure that we are prepared for them.
Yeah, it's definitely an interesting point, is that with a lot of different database systems, you can have a pretty good understanding of what the read versus write volumes are going to be, where some systems are going to be heavier reads than writes, and so you optimize for the read path, and some systems are going to be, write many, read once, and so you optimize for the write path. Whereas with BookKeeper, because it's the underlying storage layer that other systems are built on top of, you don't necessarily know ahead of time what the relative volumes are going to be of writes versus reads, where you might have something where you have one stream of data writing in, but then you have 15 different consumers all reading back out that same stream for different purposes. But at the same time, you might have it the other way, where you have 15 different streams of data being written, but only one consumer. And so you have to be able to make it tunable for optimizing to handle both of those different extremes of read versus write.
Yeah, and it has to be tunable. Also, it needs to be able to separate react, right? Because these two models can be in the same system, right? You have, at some point, you just have writes because all the reads are, for example, like, are cached by brokers. But then at some point, these readers will come up and try to read the cold data. Now you have like all these things in addition. So it is not always the same. It will spike up and down depending on the downstream consumers.
And are there any sort of interesting or unexpected failure modes that you've come across or edge cases that you've hit in the process of building systems on top of BookKeeper, and some sort of like interesting war stories that have come out of it?
Yeah, I mean, definitely a lot of war stories. In the beginning, like, we tried to do the indexing of the entries on disk with using like a LevelDB back in the day, like once it was out. The one interesting thing is that it would just sit there and like all your reads will just time out. Like, you're trying to read from disk and you're spinning up and you're spinning like one thread at 100%. So we had this kind of situation in which at some point, like, some of the nodes will stop working, like all the reads will time out. We had to take it offline, rebuild the index, and put it back online. So we kind of like get around by like doing some workaround initially, and then like having these tools to rebuild the indexes very quickly. Like, we moved later to RocksDB and tried to make sure that's when it was coming up, and to use this for the indexes. And another like war story was that when we switched to the SSDs the first time, we had these early models. So like these SSDs have like a limited lifespan. The moment you do some certain number of IOPS, then the disk will just getting like IO errors and so on. And what happens is that since in BookKeeper, like, the traffic is very well spread across all the nodes, we brought like these new machines up with all the new volumes. After like several months, we started seeing one failure, like one machine. Okay, that's fine. This fails. Take it down. We have all the 40 machines. That's not a problem. And after like 12 hours, another machine starts failing. Okay, that's okay. And then like more eventually, like all of them were like failing because they all reached the same amount of IOPS at the same time. So that was a bit stressful, but we kind of like rush it and do some tricks to like write the journal somewhere else and so on before that went down.
That's definitely an interesting firefighting scenario, because, particularly with physical machines where you have a particular lead time of being able to get new disks in, that's definitely a pretty scary situation.
It is months. It is not hours, right? So.
All right. And so for people who are interested in building a kind of real-time oriented distributed storage system, or looking for something that will work well for serving as the underlying storage layer, what are the cases where BookKeeper might be the wrong choice and they're better suited with either just a sort of a more traditional database or using something like a distributed file system such as Ceph or something like that?
If you need like modifiable data, then it's not a good choice because you can't modify it, right? Or like same thing, like if you need to do like to have like this point access, BookKeeper, the bare bone BookKeeper, it is not a good fit because it's logs, right? The table service that I took before, it is more like a key value store, but this kind of like, it's like building a database on top of BookKeeper, right? At that point, a database is what you need, right? If you need key value access. The other thing is you can create many ledgers, but it is not like infinite the number of ledgers. Like, you cannot have like billions of ledgers, for example. Like, it's not designed for that. You can have millions of them, but not hundreds of millions, for example. Like, if you have these many objects that you need, probably it is not a good choice. You should use either a database or like a system like S3 to create these objects. Because a ledger, it is not like a free concept. It is not like as lightweight as a key value in a key value store, because a ledger has metadata data on its own. So yeah, but otherwise, as a low-level storage, I think that's very flexible. But yeah, so no rewrites, no key value, and not unlimited amount of ledgers.
And as you continue to work with BookKeeper and use it for building things like Pulsar, what are some of the things that you have planned for the near to medium-term future of the BookKeeper project?
One of the things that we have been working on is mostly on the area of like improving the performance in a way, or having like more operational tooling. And also like one of the new cool features that has been worked on is using like direct IO for storage. That improves a lot performance because we're not bound by the page cache anyway, but just like going through page cache, even when we're done, has a lot of cost. So we want to get that out. And also like one area that we've been doing work is on the having a way to detect data inconsistency between nodes. Like we had already like auto recovery that if a node crashes, the data will copy from a head replicas. But this is more like I want to run, for example, let's say without a journal, and then because of that, I might be missing some of the data. But I wanted to be able to detect that in a good way so that the window of time between that data is unreplicated is much shorter, so that a new node might come up and it might be missing some of the data, but it will be able to check what it has locally and resync up immediately with the rest of the nodes. So more like having flexibility in the different kinds of deployments.
All right. Well, for anybody who wants to get in touch with you and follow along with the work that you're doing, I'll have you add your preferred contact information to the show notes. And as a final question, I'd like to get your perspective on what you see as being the biggest gap in the tooling or technology that's available for data management today.
I think that different systems for streaming and batching, I think that one of the really areas that we want to work on, and this is not just BookKeeper, but it's also like Pulsar plus BookKeeper, in a way that we are thinking of is to how to make it more working on data that is both like real time and historical, right? Bridging the gap between the batching and the streaming world, and having a system that can support both cases with a single API and single platform that can really run both. I think BookKeeper is a very good building block for that, for both worlds, between BookKeeper and what we've been building on Pulsar on top of it, and tier storage part, and different ways to store the data, historic data. I think that's where we want to get there in a better way.
All right. Well, thank you very much for taking the time today to join me and share the work that you've been doing on BookKeeper. It's definitely a very interesting project and an interesting building block for the overall data ecosystem. So appreciate all the time that you and all the other contributors have put into that. And I hope you enjoy the rest of your day.
Thank you for having me and for the nice questions and the discussions.
Listening. Don't forget to check out our other show, podcast.init, at pythonpodcast.com to learn about the Python language, its community, and the innovative ways it is being used. And visit the site at dataengineeringpodcast.com to subscribe to the show, sign up for the mailing list, and read the show notes. If you've learned something or tried out a project from the show, then tell us about it. Email hosts at dataengineeringpodcast.com with your story. And to help other people find the show, please leave a review on iTunes and tell your friends and coworkers.